Alright, here is, we're going to perform the division. And then we want to write the answer with positive exponents. So we'll look at what that means. The way these are set up, you have one term in the denominator and you have three terms in the numerator. Now when it's set up this way, it's easy to get a little lost. So what I like to do is separate them out into three terms, because you can do that. You can say the minus 40x to the 6th power is divided by the 4x to the 4th. And then you use this in between, that's plus. Then you write these two terms again, or you write this one and then with the denominator again. 48x to the 5th over 4x to the 4th. You take that subtraction and now you do 40x to the 4th over the 4x to the 4th. Now we're going to work on each one, and we're going to use the exponent rule. The exponent rule, when you have exponents of the same base, so the same base here is x, you subtract the exponent numbers like 6 minus 4. That you do that when you are dividing exponents of the same base. If I were adding those exponents, if I were multiplying these exponents, okay, in this case I'm dividing them, so I subtract 6 minus 4. Here, if I'm multiplying, then I add 6 plus 4, and that would be x10. Now I'm going to show you why the division, just briefly, why it works the way it works. Let's take this x to the 6 and just write it out as x, like write it all the way out. X times x. So x 6 times there. And then let's do x to the 4th. X times x times x times x. And let's extend that. Let's put our negative 40 in there because that's there too, but that is a number all by itself, and thus 4 is still by itself. And that's also multiplied by everything. What you can do, because any number over itself, 1 over 1 equals 1, 2 over 2 equals 2, anything in the world over itself, oops, well that was silly, 2 over 2 equals 1, any number over itself, and it could be a letter, x over x equals 1. It doesn't matter what is on top. It could be 1/2 over 1/2 and it'll still equal 1. So for all these x over x's, that's 1. We cancel them away because that's a 1. This x over x goes away because it's a 1, so it's times 1. This x over x times 1, x over x times 1. And what we're left with is x and an x over here. We're left with an x squared. So we have x squared after canceling, and 6 minus 4 is 2, so that's x squared. Whenever you have a positive integer after you subtract it, you always keep it in the numerator. Now there's x squared in the numerator, and now we just simply divide negative 40 by 4, which is negative 10. So that whole, this goes away because we divided it out. That whole clunky term here now is just negative 10x squared. So I'm going to rewrite it as negative 10x squared. Okay, let's go to our next situation here, and let's simplify that. So let's follow our exponent rules. Now that you know how it works, our exponents of the same base are these, we simply subtract the exponents, 5 minus 4. So that's telling us, that's 1. We have x to the 1 power, and when it's a positive, but when the exponent is positive, 1 is positive, it's in the numerator. Alright, so then we divide out the 48 divided by 4, which is 12. So then this becomes 12. And we keep our positive sign. So we no longer need the fraction bar. That's simplified to 12x. We don't even need the 1 there either, because it doesn't mean anything really. So we've simplified those two, and now let's simplify our last one. We are going to use our exponent rules. We have x, 4 minus 2, so that's x squared. We know it's on top of the numerator. 40 divided by 4, and it's negative 40. We have the same as in this first term, so that will be negative 10. So minus 10 x squared. So those are the same. Did I copy something wrong? I made a mistake. Okay, that's not a squared because our denominator is 4x to the 4th. Okay, so then we have 4 minus 4, which is 0. So this is supposed to be a 0. X to the 0 is equal to 1. So that makes this whole term turn into just negative 10, because negative 10 times 1 is negative 10. So what we're done with this expression. When we write it all out, negative 10 x squared, and our answer, our simplified answer, because it's an expression with, and there's nothing equal to it, so it's an expression and we simplified it. Okay, let's do the same over here. We'll break apart our little pieces. We'll take this numerator here, or this term in the numerator, negative 25x to the 9th over negative 5x to the 3rd. Keep that plus, so it's plus. So we'll use our exponent rules. We have these x's with the same base. The base is x. We subtract the exponents. It comes out 6x to the 6th. And then we divide 25 by 5. Those are dividing two negatives makes a positive, so this term reduces to 5x to the 6th. Let's move to our next term. We'll bring down that plus. We have x to the 8th and x to the 3rd. We subtract our exponents. That would be 8 minus 3 is 5. So we have x to the 5th. It's a positive, so it's on the numerator. 15 divided by 5 is 3. It's a positive divided by a negative. That is negative 3. And then we can bring down this plus. We will use our exponent rules again. X6 minus 3, that's x to the 3rd. And then we will divide. 30 divided by 5 is negative 6. We have all these plus negatives. We're going to clean that up. And then we have a minus. This will be, let's take this here. Now we have 4 minus 3. We didn't come up with any negative exponents on this problem, so I didn't get a chance to show you about that. But 4 minus 3 is 1, so that x is just a 1, x to the 1, which is just x. Negative 30, I'm going to go ahead and use this negative here. Negative 30 divided by negative 5, that is positive 6. Okay, I just changed that because I incorporated this into the 30. You can do that, but just remember to change that. Okay, now let's clean this up. Whenever you have a plus negative, that's the same thing as minus. So 5x to the 6th minus 3x to the 5th minus 6x to the 3rd plus 6x. We don't need that one. And that is our simplified expression after we divide it.